Moving on into chapter 9.4, we're going to talk about solving polynomial equations in factored form. And earlier we had learned how to simplify polynomial equations or expressions using combining like terms and then also by using multiplication. And then we started looking at sort of special products and some of the special perfect squares involving binomials, and so we're going to keep this idea going, and we're going to start learning how to solve them. So this starts off with this idea called the zero product property. Okay, and let's go ahead and write that down here. It's called the zero product property. And what this basically says that if you multiply anything times 0, you're going to get 0. So if you have an equation that looks like this, 4 times a number is equal to 0, then we know that x has to be equal to 0, right? Because the only way to get to 0 is to have it multiplied by 0. Well, what basically this goes on to say is if you have two numbers, a and b, that are equal to 0, that if a is equal to 0, then this whole thing will be 0. Or if b is equal to 0, this whole thing will be equal to 0. So you end up with two different solutions. And so we're going to use this idea to look at polynomials and look at their equation or look at their solutions. Okay, so let's go ahead and take a look at one. So here's a factored polynomial. Okay, this is before we've expanded this out. What we have is we have two binomials, right? Here's a binomial and another binomial here, and we're multiplying them to get to 0. And so basically what we have to do here is we say, okay, well, one of two things has to happen. Either x minus 4 has to be equal to 0, right? If this whole thing here, if this is 0, then it doesn't matter. If I multiply by this, no matter what this is, I will get 0. Or x plus 2 has to be equal to 0. Okay, so if I can make this part 0, then my whole thing will end up equaling 0. Okay, well, this is where x is equal to 4, or where x is equal to negative 2. And this is my solution, okay? If I plug in 4, here, this becomes 0, the whole thing becomes 0. If I plug in negative 2 here, I get the whole thing equals 0 because I'm going to be multiplying by 0. So that's the idea of the zero product property. So let's go ahead. Why don't you take a look at this problem and take a second and see if you can figure out the solution to this one. Okay, well, hopefully you looked at this and you said, okay, one of two things has to happen, right? Either this piece here has to be equal to 0, or this piece here equals to 0. Well, where is that going to be true? Well, it's where x minus 5 is equal to 0, or it's where x minus 1 is equal to 0. And where is that? Where does x minus 5 equal 0? What's when x is equal to 5? Or we have x is equal to 1. One of those two things will make it 0. Let's go ahead and take a look at another piece here. And now we have two different equations, and these two are not actually factored for us. So what we're going to do is we're going to factor them. And what I'm going to do in this first one here is I'm going to go ahead and look at it, and I'm going to say, okay, looking at this, is there anything that I can pull out of here? Are there any common factors in both this piece and this piece? Well, I'm looking and I say, all right, well, there's a 2 that I can pull out of here. And then there's also this x. There's two x's here and an x here. So I can do this and I can say 2x and I can multiply this. So I'm sort of reversing it, okay, and undoing the distributive property, okay? So I have 2x. Well, that leaves me with x here and then plus 4. And this is equal to 0. So basically what I'm doing is I'm factoring out, okay? So look and I say, okay, there's a common 2 and a common x from both of these. I'm pulling them out, okay? Finding basically the greatest common factor of these two numbers. I pull it out and I see what's left over. Well, there's an x left over and a positive 4 left over. And you can check yourself. 2x times x is 2x squared. 2x times 4 is going to be 8. And so now what I can say is, okay, well, if either one of these pieces, because it's a multiplication problem, if either one of these two pieces is equal to 0, then I get 0. So I know that 2x equals 0, or x plus 4 equals 0. Well, where is that going to be true? That's when x is 0, or when x is equal to negative 4. Okay? Well, let's go ahead and take a look at this next one. I have 6n squared is equal to 15n. Now, if you remember, the idea of the zero product property is that it has to equal 0. So I want to make this thing equal to 0. So I'm going to say 6n squared, and I'm going to subtract 15n from both sides so that I get this thing equal to 0. So I get 6n squared minus 15n equals 0, right? The whole idea, I want to make it equal to 0. So now I can look for common factors. Well, let's see. It looks there's definitely an n in both of these, and then 6 and 15 both be divided by 3. So let's pull 3n out from each of these, and I'm going to get 2n, and I'm going to be at minus 5. Okay, and that's going to be equal to 0. And that looks like I can go ahead and solve this. I know that 3n will be equal to 0, and I knew, or 2n minus 5 will be equal to 0. So I'm going to get n is equal to 0, or n is equal to 5 halves, right? Move 5 to the other side, then divide by 2. Okay? And you can always check your answer by taking these numbers and plugging them back into the original thing, right? If I take 0, well, that's obviously going to work, right? Because this will be 0, this will be 0. The 5 halves part, maybe not so obvious. You know, you plug it in. Let's see, you'd get 30 over 2, right? Oh, no, let's see. 15 times 5, you get 75 over 2. And if you plug in, let's see, this, you get 5 squared, which is 25. 25 times 6 is 150. 2 squared is 4, so you'd get what? Let's see, 6 times 5 squared over 2 squared. So you get 150 over 4, which is equal to 75 over 2. So it works. Okay? Other ways you can check your answer. Why don't you go ahead and pause the video and you try doing both of these when you when you work it out. Go ahead and hit play again. All right, well, I'm just going to go through this real quick. So I'm going to factor out a 3x from here, and I'm going to get x minus 3 is equal to 0. And I'm going to get x is equal to 0, or x is equal to 3. Okay, I know that I can plug 3 right in here, and I'm going to get 0. So that's one solution. Over here, I need to get my values or my terms all on the same side. This is a common factor of 2n. I'm left with 2n minus 1 is equal to 0. So I'm going to get n is equal to 0, or we'll go ahead and work this one out, is equal to 0. And so this one is already a solution. And then I can say 2n equals 1 divided by 2, so n is equal to 1/2. And there we go. Okay. Well, there's this one other part that we need to talk about, and the sort of the reason why we're getting to this. And there's this things called vertical motion model, okay? And the vertical motion model is where you take a projectile, which is basically like a kind of like it's something that goes into the air, but it doesn't like propel itself. It doesn't have or it's propelled in the air, but it doesn't have power to keep itself in the air, right? So like if you throw a ball can't keep itself in the air, but an airplane can keep itself in the air, right? So like a bird, you could throw a bird in the air, but a bird could keep itself in an air. But if you take something, you know, like a rocket or something like that, well, a rocket is not a good idea because it can keep itself in the air as well. But you know, basically any sort of thing you can throw, a rock, right? Yourself, you could jump up into the air. But you can't keep yourself up there. So that's what they mean by a projectile, something that needs extra power to put it up in the air. So in this case, what we're going to do is this is the model, this equation here, and we're going to use this equation a bunch of different times. And I would like you to try to kind of memorize it. And so each of these pieces here has a different meaning. So the first one is that h is the height of the projectile, and we're going to use feet for all of these. Okay, so it's how high this thing is at its highest height. It sounds kind of weird. Okay, and then t is the time of the object, or the time the object has been in the air in seconds. So from the point it begins, wherever it begins, to the point that it lands, the elapsed time there is going to be t. V is the initial velocity, or the starting speed in feet per second. So if you throw something in there, it's basically how fast is it when it leaves your hand. or if you jump, how much, how fast were you going up in the air when you jumped. And then finally, s is going to be the initial height in feet. So if you start on the ground, it'll be 0. If you start on top of a cliff and you're jumping off of it, it'll be however high the cliff is. If you're, underneath something and you want to jump up and you're trying to reach, like maybe you're trying to jump up onto a chair, you might end up having maybe like a negative starting height, or again, it could be 0. It just all depends on the problem. So let's take a look at this in action. And again, please do yourself a favor, write this down. Be very familiar with what all these things mean, because we're going to be using them a lot. Well, let's do this. Let's say there you have an armadillo in a room, and as you walk into it, you scare it. Okay, and as most things, when they get startled, they kind of jump up in the air, and so this thing jumps up in the air with a velocity of 14 feet per second. And so what we want to do here is we want to see how long will it take for the armadillo to land. So we're going to use our vertical motion model here. Okay, and so I have it written here. H is equal to negative 16 t squared plus vt plus s. And I think I actually misspoke earlier when I was talking about h. H is actually not sort of the highest point. It's going to be the end point here. Okay, so in this case, what we're doing is let's go ahead and fill in all these different pieces. For right now, let's just say h. We'll just leave it as h. Okay, and let's fill in the different pieces that we're doing. Okay, so the thing we're talking about how long will it take to land. So we're not going to know what t is, so that's what we're solving for. So let's go ahead and put 16 t squared plus, well, I know my vertical velocity, right, is 14 feet per second. I don't know time again, so I'll do t, and then plus s, and s is the starting point. Well, it starts on the armadillo starts on the ground, so we'll do 0 for the starting point. And so I misspoke when I was talking about h, because that's actually something we're going to be talking about later, is that the sort of the highest point that we're doing. So in this case, we're talking about, because this armadillo, right? So we're saying it starts on the ground 0 and it goes up in the air, right? It jumps up in the air and then it comes back down. So the height after this amount of time is going to be 0, okay? Because it's basically, after the whole time goes by, where is it? It's back on the ground. Okay, so this is sort of the ending height. And so because it landed back on the ground, it's at 0. So now we're going to get negative 16 t squared plus 14 t. Okay, and now what we can do is we can go ahead and we can factor our equation. So we're going to say 0 is equal to, and I'm going to say I've got, I'll go ahead and pull out a negative 2t from each of these, right? They're both even, and there's a t from both of them. So if I take out negative 2t here, then I'll end up with, let's see, 8t plus 7. All right? And now I can take each of these pieces, right? And so I can say that negative 2t is equal to 0, or I can say 8t plus 7 is equal to 0. And actually, I made a mistake here, because I divided by negative, okay? Because I pulled this negative out of here, this has to be negative 7. So if you want to just pull out positive t here, you'd still have the negative 8, and maybe that makes a little more sense for you. So 8t minus 7. And I sort of caught myself here because I knew my answer was going to be, I saw my answer was going to be negative there, and I know that the time can't be negative because the armadillo is not going to land before it jumped. Okay, so go ahead and say, well, t is going to be equal to 0, right? Or we can say that t will be equal to 7 over 8, okay? Which is 7/8 of a second. And so why there's two answers here, okay? Why are there two? And what I want you to do is I want you to think about this and think, why would there be two answers here for this problem? And bring this to class with you, and we'll talk about it a little bit more, and hopefully you'll have a little bit better understanding. But see if you can kind of figure out why that there are two answers here. And again, bring up any questions you have, especially about the vertical motion model. We'll do a couple more of these problems in class, but I really want you to have an idea of how to factor these, how the zero product property works, in class. So go ahead and practice some of those. These are your problems that I want you to do at home. 3 to 13 odd, 17 to 35 odd. Make sure you check your answers in the back of the book, and we will discuss more in class tomorrow. Have a good day.